Okay, so we're going to go through this next little bit here. It says, if P, so we're talking about this P now, right here, this P. If P is not the center C, so it's possible that P could be the center of dilation. It's not on this picture that we have. So if P is not the center, then the image of P prime. So this is just going to kind of talk about this picture. The image of P prime is on the line from P to C. So as you're multiplying that distance that you get is going to be along that line that connects P to C, or C to R, or C to Q. So that's why those little lines are drawn on there, because we're talking about distance. That's how we do a dilation. We double the distance, we triple the distance, we quadruple the distance from the center to P, and when you do that, it's that distance along this line. Okay, so our scale factor K is a positive number, and here's the rule that's going to happen. So a lot of this is just set up. The actual doing of the problems is not super difficult, because here is the rule. So K is our scale factor. So here my scale factor was 3. What did you do with that number 3? So I said the original distance was 2. My scale factor is 3, and you said the answer would be 6, right, for the distance? So we multiplied. That's the rule. My rule is x comma y is going to change to, and you're going to multiply your scale factor K times every x and your scale factor K times every y. Because we are going to do all of this in the coordinate plane. The picture that you see here is obviously not in the coordinate plane. But if it were in the coordinate plane, this is how we would find the new coordinates. This is the rule. Okay. If by chance, if we were doing a dilation and P happened to be the center of dilation, how far, if P and C, like if C was at P, so if you slid this over here, how far would C be from the point P? It would be right there, right, if they were the same ones. So then P would be the same thing as P prime. So if your center of dilation is one of the points, then that point will not move anywhere. Okay? So if one of your points was 0, 0, and you're dilating 0, 0 by a scale factor of 4, 4 times 0 is 0, 4 times 0 is 0. So it's not going anywhere. We have two different types of dilations. We said we can either make it bigger or we can make it smaller. So we can do a reduction or an enlargement. It just depends on what K is. Okay, so again, remember we're trying to figure out too, because I left at the top, I left a blank for when they would be congruent. Okay, so I reduce it by taking it times like a half, right? That would make it smaller. If you take half of a number, it's going to make it smaller. So you reduce it if K is between the numbers 0 and 1. We're not really going to talk about negative numbers, but I threw a negative on your homework so we could see it visually tomorrow before we move on to anything else, but you won't really deal with a lot of negatives here. An enlargement would be if K is, got an idea? Bigger than 1. Bigger than 1. So if K is bigger than 1, that is going to make the shape bigger, right? If you take it times 2, it's going to get twice as big. If you take it times 4, it's going to get 4 times as big. They're not talking about the area. We're talking about the side lengths. So how do I keep it the exact same size? What do you multiply by to keep it the same size? 1, right? You multiply it by 1 and it stays the exact same size. So going back up to the top, congruent means same size, same shape. So if I wanted to be congruent, the scale factor would have to be 1. Now, tricky little piece here is it would also be the same size if you multiplied it by -1. Okay. So I'm going to throw that in here, even though we're not really going to be dealing with a whole lot of negatives. You'll see just one time what a negative does. Okay, so what is your homework actually going to look like after all this information? Okay, so your homework is actually going to look like this. First thing we're going to do is we are going to find the scale factor between these dilations. Okay, so I want you to just take a second and just state for these 3 pictures, did I make the original bigger or did I make it smaller? What do you think? I'm just going to give you like 30 seconds to look at the picture. Did I make it bigger or did I make it smaller? See if you can catch on to the what's in the picture to tell you. Okay, so hopefully you were looking at the prime, right? P versus P prime. So if you find P, this is your pre-image. This is your image. So from your pre-image to your image, it got smaller. Okay, so this is a reduction. So because it's a reduction, when you give me my scale factor of K, you had better give me a number that's less than 1, right? So if you put, let's see, it was 15 and then I made it 10. Don't write that. What's 15 divided by 10? Anybody? Yeah, it's 1 point something. So 1.5, is that less than 1? No. So what happens is when you write me the scale factor, that's one way to check and see, did I write down the right scale factor or not? No, because you just said to make it bigger. So this scale factor would be 1.5, which would make it bigger. I don't want to make it bigger. I want to reduce it. Okay, so when you do your scale factor, here's the in general. Okay, in general for the scale factor, you're going to put the image number on top and the pre-image on the bottom. Okay, but again, if you don't remember that on the day of the test, like, oh crap, I forgot which one goes on top, pick one. Pick one, put it on top, and then see what your answer gives you. See if it makes any sense, okay? If you learn nothing else in math, step back and learn to know if your answers make sense or not, okay? That is a life skill you are going to use later on in the future, okay? Does my number for my bank account make sense, okay? So right here, the image number, so this is the pre-image, this is the image. The image number is 10. The pre-image number is 15. 10 divided by 15 reduced down is 2/3. So is it okay to have a scale factor that's a decimal? Yes. Can I have a scale factor that's a fraction? Yes. Can I have a negative scale factor? Yes. Can I have a scale factor of 0? No. That's the only number you can't have. Okay? Okay, let's go over to this one, this little stick man. Okay, so what they're going to do, so I'm going to use my whiteout here to show you something a little bit different, because this is what I was talking about at the very beginning with our pictures here. Okay, so don't look at your picture for a second. Look at my picture. Look at me. Look at me. Okay. Now, this picture is the same thing as your picture. The same thing. Do you see how tempting it would be to write 9/6? See how tempting that is? That is not the answer. Okay? When you write this on here, what you're doing when you write K, you are writing, when I write on the top, I say image number over pre-image, right? That's what I wrote down before, pre-image. Okay, when I write that down, what I mean is, what is the distance from the center to the image point. Is 9 the distance from the center to the image point? No, that distance is 15. So when I write down that image, what I mean is, what is the distance from C to P prime? So this has to be from C to P prime. Yes?
So with what you just whited out, though,
yeah,
wouldn't it have been 9 the whole thing? Because
because it was bars. Yeah,
okay.
Yeah.
But
so I just subtracted the 2 and got 9.
Then.
Yeah. Yep.
So what you do
Yep.
to find that 30%, you have to do 6 or 13.
So we would have to do, no, you just have to do 1. So this 9 right here should not show up in your fraction at all. Okay? When you add those two together, that number 15, that should be on the top with the number 6 on the bottom, done. So 15 is the whole thing, which you guys have on your paper. I widened it out, but there's 15. Add those together. So 6 over 15 reduces down to 5 over 2. Or you could write the decimal 2.5. Doesn't matter if it's a fraction. Doesn't matter if it's a decimal. However you want it to go. Okay, last one, last scale factor. So on this one, I'm just going to pick. You pick one coordinate or one letter. Do you want to do B or R or G? R. Okay. Oh, this is an easy one. 10, 10, 5. That's what R is. Okay, so you need a coordinate. So you chose R, so we're rolling with R. 1, 2, 3, 4, 1, 2. R prime is 4, 2. When you do that, you're getting distances, right? So I need to know a distance for R and a distance for R prime, okay? From the center. When we are doing in the coordinate plane, all of it is from the origin. Now, it does not have to be this Pythagorean theorem distance. I'm not asking you to do that. All you have to do is take one of your two distances, because those are distances. It's a distance along the x and then a distance along the y. So pick one. Do you want to use the first coordinate or the second coordinate? First, okay? So you are going to take the first coordinate and divide it by the first coordinate of the other one. But which one should go on top? Did this one get bigger or did it get smaller? It got smaller. Look from R to R prime. So this is a reduction again. The other one was an enlargement. So my image is actually the number 4, and my pre-image is actually the number 10. Again, if you don't remember that, put numbers down. Just put it down, step back, and ask yourself, does that make sense? Okay, so this would be 2 over 5 reduced, 2/5. Is the number 2/5 less than 1? Yes, all reductions should be something less than 1. Right? Bigger than 0, but less than 1. Okay? Okay, now let's turn the page and let's actually do this. Okay, so can we take 60 seconds to just graph these real fast? The first one and the second one, and then we'll run through the, the two dilations. I don't think so. We do have a quick meeting after school tomorrow, so I'll let you know if I get any information. All right, you ready? Got it graphed? Okay, so everything that we've done so far, I have given you the graph way to do it and the non-graph way to do it, okay? So this non-graph way to do it, because I think you're going to like that better, okay, just to use the rule. The non-graph way to do that, we'll look at that one first. This is our rule. So the rule says take every xy and multiply the scale factor times every x and the scale factor times every y. So all you are doing is multiplying 1/2 times every x value and multiplying 1/2 times every y value. Did you see where I got the half, or did you miss that? Okay, it's in the problem. It says the scale factor of 1/2. Everything is centered on the origin. It would be so much more interesting if it wasn't, but these are pretty straightforward if they're centered around the origin. Okay, so right here is going to be the center. This is where everything is centered about. So I just want to show you, before we start, we want to see what this looks like, because typically when you are making something bigger or making something smaller, you assume that it's going to get, okay, let me give you a visual here, it's going to be here. Does that make sense? So we assume that it's just going to get smaller inside of itself. Okay, and while that's true, it's going to get smaller, but the definition of a dilation is the distance between this center and this point is going to change. So this distance is going to be halved. So it's going to be in here somewhere. This distance is going to be halved. It's going to be in here somewhere. So it is getting half as big. All the side lengths are getting half as big, but they are going to clump closer to the center of your dilation. So it's similar to when you take a shape on your computer and you make it smaller. Does it get smaller on itself, or does it kind of shrink onto the side? Right? There's a fixed point, and that fixed point is where everything gets smaller too. That's a dilation. Your computer is doing those calculations in the background. Okay, so the same thing here. If you want to do this just by hand, okay, by using the rule, here's what the coordinates would be. Okay, so take these coordinates, and we're just going to half all of them. Okay, so x prime would be -2, 2. Y prime would be 1, 4. Z prime is 3, 1. And out of alphabetical order comes W, -1, -2. And if you graph those, I want you to see visually what just happened. Okay, where does that go? So -2, 2, 1, 4, 3, 1, -1, -2. And you can kind of see here where it's clustered closer to the origin than it is right in the center. It's not right in the center of its own shape. Okay, it doesn't just shrink into itself. Okay, it's going to shrink towards the center of dilation. Okay. Ta-da, we did it. That's it? That's it. Onward. So another thing you might see on your test or quiz is you might see this, a composition that has a dilation in it. So we are first going to move everything this way, and then we are going to dilate by a scale factor of 3. Do you have to graph this? Nope. We already talked about how to do this, okay? But some of you still like to move with the graph, so I'm going to move it. I'm going to do it on the graph, and then I'm going to show you what that looks like. If you want to just pull the coordinates through this rule and then multiply them all by 3, you will get to the same answer. But I'm going to show you on the graph what that looks like. So some of us we still like doing the graph, and that's fine. Okay, so on the graph, I'm going to move, this means I'm going to move left. I'm going to move everything left 3, and I'm going to move everything up 2. Okay, so I'm just going to count 3 to the left and up 2 for each one of these coordinates. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So that is actually super quick. So that's why some people like to do it on the graph. I didn't have to think. I just had to count. You just have to know which direction you're counting. Okay. Now comes the dilation part. So if you are doing a dilation on the graph, what you do is you count the distance. So from 0, 0, the distance to my first point over here is 1. I need to triple that distance. I need to make that distance 3. So now I go 1, 2, 3 from 0, 0, and there is my new N double prime. Count my distance from 0, 0 up to, that is point M. That's 1, so now I'm going to triple that. 1, 2, 3. There is my new M prime. Count my distance to L, which is over 1, down 1, and I just need to triple that distance. So I'm going to go over 3, down 3, and there is my new L double prime. So here is my new triangle. And that one, more so than the last one we did, does look centered, but that's because the triangle we dilated was right around the origin. Okay, so our final coordinates, if you did the rule form, it doesn't matter how you do it, you can do it in the rule, you can do it on the graph, the final coordinates should be N double prime is 3, 0, M double prime is 0, 3, and L double prime is -3, -3. Ta-da!